Good evening and welcome to the July Madison DX Club program. Tonight, we have one of our favorite and most popular speakers, Carl, K9LA, and he's going to tell us that we're up on the top of the mountain and we're about to go down the slide. And we all hope it's not too steep. We hope there's no avalanches. But I guess the old saying that whatever goes up must come down. So Carl, tell us about what's happening with the solar cycle and your kind of thoughts and predictions.
Oh, come on. There we go. Yeah, I finally got unmuted, I guess. Everybody can hear me? Uh-oh.
Yes.
Oh, okay, good. So I'm Carl, K9LA, Fort Wayne, Indiana. And there's my email if you want to ask a question or whatever. There's my website mostly about propagation and solar topics. And I plan to send a PDF to Bob of this presentation. You can do whatever you want with it. There are some URLs listed, so it'd probably help to have the PDF. So the topic tonight is the downside of solar cycles. Now there's kind of two meanings there. The downside is just, so what's going to happen on the decline of cycle 25? And the second interpretation is what are the bad things that are going to happen on the decline of cycle 25? And that cartoon, of course, uses cycle 24 because cycle 25 is not exactly even near solar minimum. We probably still got 6, 7, 8 years for that. Okay, let's get started. Hopefully this thing will advance. Yes, it will. Here's what I'll talk about is I'll give a quick update on cycle 25. That's always good to see. And I'll talk about where it may be headed, one peak or two peaks. Is it declining now, or is there just a pause in its ascent? And when I show a plot on a subsequent slide here, you'll see why it's hard to tell if it's if we're in its decline yet. So whatever. Also talk about propagation going forward for the next year, 2, 3. Got to talk about geomagnetic field activity, especially during a declining portion of a solar cycle. And I even threw in a couple slides on cycle 26. So, hey, I can make a prediction for cycle 26 now because I probably won't be around for it. So that's good. Okay. Now, just realize I'm an electrical engineer out of Purdue. I'm not a solar physicist. And I strongly suggest you visit the Front Range 6 Meter YouTube channel. I plan to add the Madison DX Club YouTube channel because I think Dr. Scott McIntosh has spoke at your club meetings, I believe, too. And whichever YouTube channel you go to, take a look at some of his presentations because he's really good. He's a solar physicist. So, and his latest presentation, at least to the Front Range 6 Meter group, was earlier this year. So it's kind of up to date. Okay, here's cycle 25. The thick red line is cycle 25. Of course, it's still in progress. It's also has a small solar cycle, cycle 24 in green. The average solar cycle, if you take an average of all previous 24 cycles, that's what cycle 23 peaked at, about the average of all 24. And there's a moderately big cycle, cycle 21, peaked in, I think it was December 79. The latest data includes the June monthly mean sunspot numbers. And of course, that is further average to give the smooth sunspot number. And that ends up, the smooth sunspot number is 6 months behind the monthly data. So that's why the latest smooth data is for December 2024. So cycle 25 is between an average cycle and a small cycle. Will it reach or exceed an average cycle? So let's look at that. First, I'd throw in some a slide on the smooth values, and what is a smooth value? Why do we use it? Well, there's a plot of cycle 23 in terms of the daily sunspot number. That's the red data. Of course, you can see that's very spiky, and it's hard to tell what's going on. You get a general idea that things went up and then they went down. The blue data is the monthly mean. In other words, like June, you'd take all the daily data in June and average it, and that's a monthly mean. That's, like I said, that's the blue data. It's a lot better, but it's still spiky. So that's where the smooth values in green come in. It averages 13 monthly mean values. And you can see all the spikes are gone, and it's easy to see what the solar cycle did. In fact, the smooth values define a solar cycle. And that also includes the 10.7 centimeter solar flux if you plot that. Now, smooth values give us the best understanding of the ionosphere. Unfortunately, it's a statistical understanding, not a deterministic daily understanding. That's a whole other subject. So smooth values are used to define a solar cycle and help with our propagation predictions. Our solar cycle data the good data began in 1750. Solar flux only started in 1947. So that's why we still keep going with the sunspots, because we have a heck of a lot longer data record. What are you doing? You've got 8 cats, so they're usually getting into trouble here. Okay, now let's go back to cycle 25 data and see the little circle there. And note that November and December 2024 smooth sunspot numbers declined. And that was the first time the smooth sunspot number declined for cycle 24. There was some leveling off in the earlier months, like 14 to 51. You can see it kind of leveled off. So that was kind of, makes you wonder, well, does that mean cycle 25 is beginning its descent, or is it just kind of go up and down a little bit here for a couple more months? And that's what that first question is. Is this just a pause in the ascent of cycle 25? I'll mention that cycle 24 had a similar decline early on, but it went to a second peak. So maybe we're seeing that. Don't know yet. Or is this just the start of the actual decline? Now here's a little picture of 2 conflicting solar cycles. Cycle 21, you can see it appears to have started a decline in 1980, and then it continues its descent. And then along comes cycle 22. After it appears to have started a decline in 1990, it went into a valley and then peaked again and gave us a second peak. So not sure we understand deeply why we have 2 peaks. It has to do with asymmetry in the 2 solar atmospheres, the southern and northern. So we'll get into that a little bit. Okay, don't get on the keyboard there, buddy. So is cycle 25 going to have 1 or 2 peaks? And of course, that's going to determine how long we have 15 through 6 meter propagation. Now, there was a little hiccup there in cycle 25. The green is the total sunspot number. Orange is the southern hemisphere sunspots, and or orange is the southern, and blue is the northern hemisphere. And you can see what caused cycle 24 to have 2 peaks. Initially, the northern hemisphere was very active, but the southern wasn't. And then that switched a little bit later on. the southern hemisphere was active and the northern hemisphere didn't do much. And that gave us 2 peaks. On the right is the data for cycle 25. As I said, you can see the rise of all the sunspots there. There's a little glitch there, and it's circled. And is that a peak? And that's one of the questions I don't think we can answer yet. I don't think we have a definition of a peak. So what I think a peak is, or 2 peaks is, there's a significant valley in between, just like you can see in the green curve on cycle 24. Now, if we call that a peak on cycle 25, then cycle 24 really had maybe 3 or 5 peaks. So it's still up in the air, and there's still a question, will the northern hemisphere come alive in cycle 24, the blue curve? And if it does, without the southern hemisphere going down too much, we're going to probably have a second peak. But we're just going to have to wait and see what happens. And here's a little picture of cycles 21, 22, 23, and 24. You can see cycle 21 there in blue at the top. It didn't seem to have a second peak. It kind of looked like it tried to, but it didn't have one. Then along comes cycle 22, and it had a nice double peak. Along comes cycle 23, red. It had a double peak also. Cycle 24, although it was a smaller cycle, it definitely had 2 peaks because there's significant valley in between. And there in green is the cycle 25 data to date. We're just gonna have to wait to see what happens. So cycle 22 kind of appears to have started the recent 2 peak trend. And will cycle 25 end it, or will it continue it? Don't know. Okay, again, back to the cycle 25 data. Note that cycle 25, in terms of the smooth sunspot number, is 60 months. Well, there's a typo there. It's not 1 year, that's 5 years. I'll correct that in the PDF I send you guys. And note it's 60 months. We have 60 months of data after solar minimum in December 2019. Okay, let's look at what a typical solar cycle looks like. Okay, there it is. Of course, I think everyone knows it's an approximate 11-year cycle. Now, on average, the rise time from A to B in that sketch on the right is 4 years. It's the average of all 24 solar cycles. Descent time, B to C, is 7 years. So generally, a solar cycle rises and its decline lasts a lot longer, or a couple years longer. Okay, 3 years longer on average. So cycle 25 is about a year longer than the average 4-year rise time. That may suggest that cycle 25 may be in its descent and not in a pause. Again, all I can say is we'll have to wait and see. Now, here's some interesting data suggesting cycle 25 is in its descent. It's from that URL there, solen.info/solar. It's a year's worth of sunspot number, 10.7 centimeter solar flux, and AP. Now, included also are trend lines for the sunspot number and 10.7 centimeter solar flux. But just looking at the plot without even knowing what all that data is, you can see there's a downward trend. And that sort of suggests that cycle 25 is finally in its descent in terms of the smooth sunspot number. Now, the red data is the sunspot number. And the 27-day average of the sunspot number is in violet. It's still going up and down because there's you could average it more and see better, but you can see it's trending down the violet line. The solar flux is the black data, and the 81-day average solar flux is that brownish trend line, which it's going down also. And this downward trend has been going on since about mid-2024. The left side of that chart is August 5th, 2024. So it's definitely been going down. Now here's my version of slide 12. There's another typo. It's only for sunspots though. So there's not a lot of other data clouding up the issue. So there's the daily sunspot number all the way through January 2024 to June of 2025. And I added a sixth order polynomial trend line. And you can see there's a definite downward trend. The correlation coefficient for that trend line is about 0.54, which, might as well toss a coin really. So it still suggests that there's a downward trend, at least for now. Notice at the end there, it's looks like it's starting to come back up, and we'll have to see what happens in the next several months with cycle 25. Maybe it will give us a second peak. Now here's the most recent prediction from NOAA for cycle 25. We're about midway through 2025 there, as annotated in red on that chart. And you can see their prediction is it's gonna start declining pretty much where we are right now. But you gotta remember that NOAA initially under-predicted cycle 25, so take it with a grain of salt, but it's about time for cycle 25 to start descending. Okay, so what's propagation looks like going forward here? I think it looks like cycle 25 has started its descent, or is very near the start. Like I said earlier, the next several months will hopefully tell us what's going on. Now 160, 80, 75, 60, 40, they're going to be best at night around solar minimum, which probably is going to hit around 2030 and 2033. But the electrical noise environment has increased, so that's not going to help. It's going to make it tougher on 160 and 80, 75. And there may be some other adverse processes going on too. I continue to wonder about the increasing CO2, because I've seen papers that say more CO2 produces more electrons down in the lower ionosphere. Well, the lower ionosphere is where absorption occurs. So if there are indeed more electrons being produced because of CO2, then that's not going to help us at next solar minimum either. That's something to look at here, and hopefully I will in the future. 30, 20, 17, well, those are generally good throughout a solar cycle. Of course, they'll be better as they approach solar max, especially 20 and 17, but there's still bands that are useful throughout a whole solar cycle. Okay, 15, 12, and 10. Of course, they're best during the day in the fall and winter months around solar maximum. We need a smooth sunspot number of about 100 for daily worldwide propagation on 10. If you go back and look at the update on cycle 25, we're around 160 right now, so that's good. And what that also means is we should have great propagation on those bands out to the fall and winter of 2025 and 2026, and perhaps even out to the fall and winter of 26, 27. So we've got 2 more good seasons of high band propagation. Now, what about 6 meters? Well, if cycle 25 is indeed in its descent, 6 meters will likely have openings via the F2 region in the fall and winter of late 2025 and early 2026. In other words, the fall and winter of 2025 and 2026. And the openings will probably be similar to what we had in 2023, 2024, and early 25. So no improvement if cycle 25 is headed downward. Now, if cycle 25 continues its ascent, in other words, we have a second peak, then we'll have more openings in late 2025 and early 2026 than in the 23, 24, early 25 period. Again, we'll just have to wait and see what happens, and keep your eye on the band, that's for sure. Okay, disturbances to propagation. I need to throw that in because there's an impact on the declining phase of the solar cycle. First of all, there are 3 disturbances to propagation: geomagnetic storm caused by coronal mass ejection or a coronal hole. It causes elevated K indices and depletes the F2 region electrons for days. So that's not good. And then solar and the coronal mass ejections generally occur most likely around solar maximum. The coronal holes are most prevalent during the declining phase of the solar cycle. Solar radiation storm appears to be caused by a CME in conjunction with a big solar flare. And there's more absorption in the polar cap for a couple of days. So that one doesn't affect us as much as a geomagnetic storm. And of course, there's the radio blackout caused by a big solar flare, and lower frequency signals disappear on daylight side of the Earth for about an hour or so. And there's a sketch of this typical solar cycle. There's solar maximum when solar flares and CMEs are most prevalent. And the declining phase, that's when the coronal holes are most prevalent. So let's look at the planetary A index over a solar cycle, and it did that for cycle 24. AP is the daily average of the 8 3-hour K indices. And generally, there are 2 peaks in the AP index. One is around solar maximum due to coronal mass ejections. You can kind of see that right here from 2011 to 2014, and that when the first peak occurred for cycle 24. And then during the declining phase, AP went higher than at solar maximum, and that's due to the coronal holes. And the declining phase of a cycle is worse than solar maximum in terms of disturbances. But the ionosphere is very dynamic. Always check the higher bands, 15 through 6, for enhanced propagation at low and mid latitudes when there's a short-term moderate spike in the K index. And here's some examples on the next slide. The top one is from the 2018 California QSO party. On the left is the MUF at the Boulder ionoson. Now, interestingly, Boulder is about halfway in between California and the Midwest. And it's about a 3,000 kilometer path. So that data is very interesting. All the way up to the contest on Saturday, you can see the MUF is only around 20 megahertz. So there were no W6s to work on 10 meters. But you can see about starting on midday Sunday of the contest, which is the 7th, there was moderate spikes up to 5. And you can see what happened to the MUF over Boulder, which would really say what's going on between the West Coast and the Midwest on 10 meters. The MUF got up to about 31 megahertz. So that said 10 should be open, and it sure was to the W6, and I worked a lot of them. So that's a good one. Here's another example. This is for ionosons at low latitude paths, kind of low latitude path. This one's in, one on the left is in Peru, and you can see what happened. The MUF is just going up and down and up and down, and then the K index went up to 5 and then 6, and the F2 region took a dump. So that one certainly didn't help. The spike in the K index certainly didn't help. But at Eglin Air Force Base, here's its ionoson data, and the MUF is going up and down and then the K index was elevated to 5 and 6. This is on the same day, both of these. And you can see what happened to the MUF. Man, it went up quite a bit. So it's just a matter of luck if an enhancement occurs, but it's always good to look for it, that's for sure. So what's cycle 26 going to do? There's actually a very early preliminary probabilistic estimate for cycle 26. It comes from NOAA, it's a Space Weather Prediction Center. There's the URL of the paper, the article, or whatever it is. And they say their median prediction, in other words, 50% probability, it's going to be slightly smaller than an average cycle. That's kind of where we are right now in cycle 25. But again, it's kind of early to make a prediction for cycle 26. We'll have to see what happens. Now, Dr. Scott McIntosh, I mentioned him because he's given lots of presentations to the Front Range 6 meter group, and I'm pretty sure he did some for the Madison DX Club too. He has defined solar cycles in terms of the termination date, and that's when magnetic field, it has to do with the magnetic fields inside the sun. And once the termination date for cycle 25 is fairly well known, it's going to be more years out, that's for sure. Dr. McIntosh and his colleagues will make a prediction for cycle 26. And they may make several predictions as the data comes more and more and things appear to be headed towards something. So we'll have to wait and see for that. Very early on, I made a prediction for cycle, that should be cycle 25, I'll correct that. There's the recorded history of all 24 solar cycles. And you can see that there have been 3 periods of large cycles. Cycles 1, 2, 3, 4, cycles 7 through 11, and cycles, let's say 17 through 23 were quite large. It also says there's been 2 periods of small cycles. You can see cycles 5, 6, and 7 were quite small. In fact, cycle 6 is the smallest in recorded history. Cycle 24 was the 4th smallest. So does that mean cycle 24 heralded in a 3rd period of small cycles? So what I looked at was the duration of solar minimums and what that meant to the next cycle. I defined the duration of the previous minimum as when the smooth sunspot number was less than 20. And there's the data. There's a linear trend line, a pretty good correlation. And of course, it says that the longer you spend at solar minimum between 2 cycles, the smaller the next cycle is going to be. Now, the smooth sunspot number between cycles 24 and 25 was below 20 for about 42 months. And that my predictions suggested cycle 25 would be around 140. Well, I missed it. Cycle 25 is going to be at least 160, and it could be even more if it has a second peak. Oh, well. Okay, here's our summary. Cycle 25 is between cycle 24 and 25. Cycle 24 and 23, that's correct. And cycle 25 may or may not be in its descent. My guess is we'll only have 1 peak, but it sure would be nice to have 2 peaks. And it all depends on, I think, what the northern solar hemisphere is going to do. 15, 12, and 10 should be good throughout the fall and winter of 2025, 2026, and perhaps even out to the fall and winter of 2026, 2027. Keep your fingers crossed. And we'll probably have more geomagnetic storms during the decline of cycle 25 than at solar maximum. That's because coronal holes are most prevalent during the declining phase of the solar cycle. Now, how does this affect sporadic E? And that's something interesting to look at. And you can see the skier, I think, didn't turn out too good for him, but oh well. Hopefully it'll turn out better for us. So that's all I had. Bob and Kevin, I don't know if Bob's back, but Kevin, I know you were there. So, oops, there you are.
Yeah, I think Bob may,
questions?
may be back. Carl, that was great. Do we have questions for Carl about the presentation?
I have a question.
Or
Go ahead, Gary.
go ahead.
Yeah, Carol, you showed some slides that showed the comparisons in the northern and southern hemisphere sunspot numbers, and the northern hemisphere is underperforming with respect to the southern one. Is there any sort of a comparison or how the peaks of the respective hemispheres, although they're separated in time, tend to how equal they are in any given sunspot cycle or statistically?
I think that's a good question for Dr. McIntosh. I think he's deeper into the solar physics and probably has better insight to what may happen between solar hemispheres. But I don't think we have firm, detailed answers, even statistical ones yet. Yeah, so don't know what's going to happen. It seems like it should at least continue at that level, which will help. Maybe not have another peak, but at least keep going for a while. And of course, we have to hope that the southern hemisphere doesn't continue its apparent downward trend.
Thank you.
Okay.
Other questions? Carl, I'm wondering if you've heard from, any of the NOAA folks, how the new solar imaging satellites might be affecting, their future predictions. I mean, I think this is probably the first cycle where they've really had some heavy duty imaging going on, and I'm wondering if any of that data might be of use to them and to us ultimately.
That's probably a good question for Dr. McIntosh. I'm not aware of the ongoings inside NOAA and all that with those satellites. So, yeah. That's a good question. Maybe I'll take a look at see if what I can find at least.
Yeah, we should try to get him back again because we had him right at the minimum, I believe, and like you said, he was predicting kind of a so-so cycle,
Yep.
and we all realize that we just don't have millennial data. We have rather limited data. And
initially, Dr. McIntosh and his colleagues predicted a pretty big cycle. But then as they saw the data come in, I think it was August of 2021, they revised it down to just above an average cycle. Right now, it's just below an average cycle. So there's still a shot that their prediction will be more close to what really is going to happen. So we'll see.
I have a question.
Do we have another question?
Yeah, can I go ahead?
We can barely hear you, Derek, if that's Derek.
Is this any better?
That's a little bit better, yes.
Okay, my question has to do with what is the explanation for the difference between the sunspot numbers in the north and the southern hemisphere, if there is one?
Well, what's the difference between the sunspots in the northern hemisphere and the southern hemisphere? We know that the process of generating sunspots has to do with how plasma flows in the sun and how the magnetic field varies in the sun. I don't think we have enough detailed information to say what actually is going to happen. We still need more understanding of physics of that big orange ball in the sky. There may be papers out there on why people think the two hemispheres are not working together. And I think I'd seen a paper a while back, and it had had everything to do with how the magnetic fields are flowing inside the sun, which I don't know how accurate that information is yet, or if it's still being pursued at the depth, the depth needed to understand it. I don't think I can answer your question, Derek.
Thanks for trying anyhow.
Okay.
Carl, this is Walt, Alpha Juliet 6 Tango in Tennessee.
Hey, Walt.
You barely touched on 6 meters and
Yep.
sporadic E, but I have a question for you about sporadic E. 2 questions, actually. It appears, just watching the diurnal variation in sporadic E during the summer, that is linked to sunlight. But on the other hand, I'm told that the ionization is really all due to meteor ablation, and that sunlight does not really play a big role in 6 meters sporadic E.
Yeah.
The other question is, why is 6 meters sporadic E so much better at the bottom of the sunspot cycles?
Well, that's 2 good questions. The first one is, yeah, I don't think, well, okay, if you look at the pattern of sporadic E over a year, it's best in the summer. And there's a small peak in December, okay? And if you look a little bit deeper, on a summer day, it's most prevalent around late morning. And it's somewhat prevalent in the early evening. And I think, I saw a paper that correlated meteor deposition with sporadic E pattern, and it correlated very well. In other words, the maximum deposition of meteors into our atmosphere is in the summer months during the late morning. And now, just because they're well correlated doesn't mean there's a cause and effect. Things can happen at the same time and lead you to believe that they must be related, but maybe they're not. But it sure seems like it's really mostly deposition of meteors and when that happens, and not really on sunlight. And your second question was?
The second question is, why is summertime sporadic E so much better at the bottom of the sunspot cycle? This past summer so far has been just terrible.
Yeah. Well, I've seen other plots of sporadic E occurrence versus year, and it says there's not a very prevalent correlation, which says sporadic E is aptly named. It's sporadic. And again, we just don't understand all the processes. I know Jim Bacon, G3YLA, he's a retired meteorologist, that's a big word, for the BBC. And he's looking at events in the troposphere, where our weather occurs, that could trigger sporadic E. In fact, he has prediction maps every day of sporadic E. I'll add that to this presentation. So if you want to go look at that, that's pretty interesting. Turbulent events in the troposphere, it looks like could somehow trigger sporadic E or organize all of that meteor debris into a thin layer, a very thin, highly dense layer. So again, I can't give you a detailed answer. We just don't understand it.
Carl,
Yes.
this is Ron K0Z. Are you familiar with Dr. Jim Kennedy's work, K6MIO?
Oh, yeah.
Yeah, he has an interesting paper. It's been published in the Central States VHF Society's proceedings, I think about 5 years ago. But he talks about the electrojet surrounding the equator, and then you have these geysers that come up, and a lot of the meteor, along with even thunderstorms, electrons there are deposited with these geysers that go along the magnetic lines. It's heady stuff. I don't profess to say I understand it all, but it is interesting. Walt might be interested in that.
Yeah, if what I have all his papers, I believe, and I can put them in on a slide here in this presentation, so you can go collect them and read them. And a lot of it's on F2 propagation, but he does have some on sporadic E. And he's in, I think he's in Florida now, right? He retired and moved to be closer to the grandkids or his kids or whatever.
Hey, Carl, this is Dick at K9LA.
Mm-hmm.
I have sat through a number of your presentations. I got to say, this is the first time. I'm glad we're hanging on this slide. This is the first time I've really seen a northern and a southern hemisphere sunspot numbers. And I'm looking at cycle 24. 25, they're kind of similar, but 24, they are so different that the northern, us in the northern hemisphere had a very different 24 than the southern hemisphere did. It almost makes that green line irrelevant, right? Because nobody really felt all of it. We all had different aspects. Is there a relationship between the northern and the southern? In terms of hearing signals or whatever, like I'm struggling with understanding the difference of the northern and the southern and what it means for all of the above. You know what I mean?
Yeah, well, until we understand how the magnetic fields and plasma move within the sun, I don't think we can explain it.
I think that Dick was thinking that propagation in the northern and southern hemispheres of the Earth.
No, this is solar hemispheres.
Correct.
Okay. All right. Thank you for Brian. Thank you for clarifying that for me, because that's exactly what I was going. Is like, how can that even be measured? But
yeah, that's right.
So okay, thank you. I'll put my dunce cap back on.
Okay. Yeah, I should change that plot title to say smooth sunspot numbers by solar hemisphere. Yeah, make it more clear. But you're not the first one that asked that, so don't put the dunce cap on.
Yeah. Hey, Carl, Nick V7DXR here.
Hey, Nick.
Hi. Okay, your cycle 24 and 25, you have the northern hemisphere sunspots peaking first in both of them. Is that common to all sunspot cycles, or is it just, or haven't we observed them long enough to be able to say, or?
I don't know how far back we have sunspots by solar hemisphere. I know there's probably data before cycle 24, but probably not too much before that. But that's something interesting to look at and see if, what does the northern and the southern hemisphere in cycle 25 was quite similar for a while. Mm-hmm. And then something happened. Who knows?
Yeah. It's also, just that it strikes me that maybe there's some stuff in Scott McIntosh's work, that says, that addresses this issue, or I guess more along the lines of trying to explain why there's this difference.
Yeah.
But a lot of it goes over my head. So anyway, I'll shut up now. Thanks very much.
Okay. In fact, if you go to the Front Range YouTube and the latest presentation from Scott, he talks about, he thinks that the northern solar hemisphere is gonna do something interesting. And he probably explained why.
Yeah, and I want to, when talking about the federal.
We do have butterfly diagrams going back quite a
Yep.
while, so we
Oh,
could
yeah.
actually, do retrospective on that. But one thing that I think Scott's looking at is always the magnetic
Yep.
polarity of the two hemispheres.
Yeah. Yep. Yeah, so that's an interesting, our sun's an interesting thing. Yep. Why heck, we just, we just discovered a galaxy at a redshift of 13, which says it formed probably about 13.6 billion years ago, which was not much after the Big Bang. So that's really got people talking about what's really going on. And it would seem that understanding the sun is easier than understanding the universe, but I don't know. Maybe we just need some more, maybe we need, some very temporary probes that at least get some data as they go towards the center of the sun. To see, maybe we could figure out what's going on.
Carl, there is something that's going on relative to that. It's called the Parker Solar Probe,
Okay.
and that's actually flying through the chromosphere
Ah,
and has for about 20 revs now. Part of the Parker mission is to measure the magnetic field lines around the prominences and the holes,
yep.
and to determine things like why is the chromosphere and the solar atmosphere so much hotter than
Yep.
the surface.
Yep.
Now, a lot of that so far by the research has been correlated directly to the magnetic field lines. So some of the data that Parker is gathering
Mhm.
has to do with trying to map those field lines and do that correlation. So I think when all of the data is in and the research is completed, or as it proceeds, we're going to start to see some discoveries about the magnetic field lines and how they relate to these things. But I think that's part of the explanation behind northern hemisphere and southern hemisphere. It's that complex field, magnetic field that exists in the sun that also gives rise to the sunspots
Yep.
and the solar cycles.
Yep. Lots of interesting stuff, and it's hard to keep up on all of it. Yeah.
I just mentioned to the group that it was Dr. Douglas Biesecker, who was a section lead at NOAA, who gave the presentation to us, and that was back in November of 2020. So that's still up on our YouTube channel.
Okay.
So it might be kind of interesting to go back and just see how something almost 5 years ago
Yeah.
came out.
Okay. I will go do that. That's for sure. So
And
did Dr. Scott give presentations to the club?
no, I don't think so. I think Biesecker was the only
Okay.
NOAA guy that we got. And
Okay.
and
I'll
he
go
did-
take a look. Yeah. Okay.
So other questions for Carl?
Now, if the sun would consisted of inductors, capacitors, and resistors, maybe I could figure it out, being a double E, but
No, we don't really understand what's in our oceans, to say nothing about what we understand in
yeah.
our solar system, to say nothing about the universe and so forth. So
Yeah.
we do live in a great age of discovery. There's no doubt about it. But
Yep.
I sometimes think that as we talk about, solar cycles and so forth, we're just a notch above those who used to read tea leaves to predict the future as well. So
Yep.
more, whether it's a Parker solar probe or just more analysis or more time, we just need you to keep coming back to us for the next, 2 or 3 cycles, Carl, so.
Right. Well, I'll be 78 at the end of August, so I'm not sure I'll see the peak of 26, but we'll see. Of course, I may see it, but I may not understand anything about it. Or what is ham radio? I don't know what it is. Yeah.
So any final questions or comments? Carl, I want to thank you again. These are
Okay.
always really interesting, thought-provoking
Yep.
programs that you bring to us. We really appreciate the effort you put into getting these things pulled together and relating it back to DX. So that's wonderful. So
No, appreciate it. The nice comments. Yeah, there's so many topics that you can drill down into. So I'll be welcome to come back and do something else in a couple months. So.
Well, that would be great. I'm certain Bob will track you down.
Okay.
As he always does.
And I'll get the PDF to you guys probably tomorrow sometime.
Okay, that's great.
Okay.
So with that, I wish everyone good DXing and a good evening.